Hi friends, in this video we are going to see how to apply superposition theorem in a problem consisting of dependent as well as independent sources. So here is the problem in which we are having these two independent sources and one repeat. So in this problem we are having two independent sources and one dependent source, and for this problem we are supposed to get a current flowing through 10 ohm resistor. This is a dependent voltage source controlled by this current I. So let's list out number of independent sources in a problem given. So I'm having over here 4 volt voltage source, and 10 ampere current source. Remember, we have just considered the independent sources, and 2I is the current controlled voltage source. So these two are independent sources, whereas 2I is the only dependent source. So what you have to do in a superposition theorem? One independent source at a time we have to take, replacing other independent source with its internal resistor, but while doing so we will not touch dependent source at all. So let's consider 4 volt voltage source acting alone. What we are supposed to do to 10 ampere, being a current source, its internal resistance is infinite, and infinite resistor implies it's open circuit. So we will open circuit 10 ampere current source. So by doing so, we are changing the circuit. So 10 ampere will be open circuited. By doing this open circuit, this 4 ohm will also get open circuited. So what will happen? In the end, this entire branch will go. So how the circuit will look like? We will draw it. So dependent source will be there as it is. This is 4 volt acting alone. All the resistances will remain as it is. So we will get a resultant circuit like this, considering an open circuit of 10 ampere that will make this entire branch as open circuited. So in the end we will get circuit like this. And this 2I is the dependent source whose magnitude depend upon this current I. So if you see carefully, there are 3 meshes we are getting. So let's analyze for mesh analysis. Let's consider this as a current I1, this as current I2 in the mesh 2, and let's consider this current as I3. Now depending upon the current pass through the resistor, you will get a voltage drop like this, plus minus because of the I1, because of the I2 it will be plus minus like this, for 6 ohm plus minus, then for 2 ohm plus minus in this manner, and because of I3 you will get voltage drops like this. So we are ready to apply Kirchhoff's voltage law to mesh 1, mesh 2 and mesh 3. So let's apply KVL to mesh 1. Mesh 1 is this. Let's start from this voltage source. Plus minus minus 2i plus minus because of the I1 minus 2i1 minus plus, this is because of I2, so plus 2i2 plus minus minus 4 plus minus minus 2i1 equal to 0. The only thing over here is that this small I is given by them, so we need a substitution equation. So substitution for the small I we will find out in the circuit. If you see carefully, I is the current given in this direction for 8 ohm and we mark the I in this direction. So both the current directions are mismatching. So I can say I is minus I3. So wherever there is a small I in our expression, we will replace it with a minus I3. So if I put the minus I3 over here and if I simplify the rest of the things, I will get a equation as minus 2i1 will become minus 4i1 plus 2i2 as it is, and by putting small I as minus I3 over here, I will get this term as plus 2i3. Constant on another side of equation will be plus 4, equation number 1. This is a simple equation I will get in terms of mesh currents I1, I2 and I3. Let's apply KVL to mesh 2. Let's start from this voltage. Repeat. Let's start from this resistor plus minus minus 10i2 plus minus minus 6i2 minus plus 6i3 minus plus 4 plus minus 2i2, this is because of the current I2, and minus plus 2i1 equal to 0. So in this equation it is quite straightforward. After rearranging the terms, I will get first of all I1 terms as 2i1, then I2 terms I will have a minus 10, minus 6 and minus 2, that will give me minus 18i2 and 6i3, constant plus 4 on this side of equation. If I take another side, so it's a minus 4, equation number 2. Second equation I will get like this. And finally I have to apply KVL to mesh 3. So let's apply KVL to mesh 3. Let's start from this 6 ohm resistor in the I3 direction, that is plus minus. So minus 6i3 minus plus 6i2, and over here plus minus 8i3 equal to 0. Upon simplifying, I will get equation 6i2 minus 14i3 equal to 0 as equation number 3. So we have these three equations. Upon solving these three equations, we will get the value of I1, I2, I3. So upon solving, we will get the value of I1 as minus 0.898 ampere I2 as 0.1429 ampere and I3 as 0.0612 ampere. Now our objective is to get the current flowing through 10 ohm. So current flowing through 10 ohm I will get as I2, which is nothing but 0.1429 ampere, and the direction is downward as I mark, and this is the current is because of 4 volt acting alone, so hence I mention it as I10 ohm dash. So I10 ohm dash is the current because of one source acting alone. Likewise, we have to solve for another source which is nothing but a 10 ampere. Now in second case we are considering this 10 ampere. So whenever 10 ampere is there, 4 volt need to be replaced by its internal resistance, and internal resistance of ideal voltage source is 0. 0 implies it is short circuit. So let's solve for 10 ampere. So what we have to do, this 4 volt will get replaced by a line which is nothing but a short circuit. So we need to redraw the circuit by considering this change. 4 volt is shorted, all the resistances will be intact. This is 10 ohm, 6 ohm, this is 8, 2, 2 once again, this is 2I, 4 ohm, and this is a source which is acting alone, which is 10 ampere, 2I, where I is current flowing through 8 ohm given by them. Now there are 4 meshes we are having, 1, 2, 3 and 4. Out of that, in one of the mesh the current source is present, so its mesh current will be fixed. So let's mark current over here as I1, over here I2, this will consider as I3, and this will be I4, which is current source present in the loop. So let's mark the polarities of voltages across resistor. This is because of I1, this is because of I2, and this is because of I3, and finally I4 will also have voltages in this manner. So I'll do one thing, since current flowing through this loop or mesh is fixed by the current source, I can straight away write I4 as 10, and we'll treat this as a variable. That means wherever there is I4 present, I will replace it with 10. Now we'll apply Kirchhoff's voltage law to mesh 1. Okay, starting with this, so it's minus 2I, minus 2I1, plus 2I2, minus 2I1, plus 2I4 equal to 0. Now I4 is 10, I will replace over here, so I need a substitution for I also, so let's do that also. So what is the substitution equation? So substitution equation, we need to find out, this is the I is the current flowing through 8 ohm. This time there are 2 currents flowing through 8 ohm. One is I3 in this direction and second is I4 in this direction. So there is a subtraction of two currents and the current direction given by them is matching with the I4. Hence I4 is greater. So I can say this is I4 minus I3. So it's a very important. And we know I4 is 10. So we can further reduce it to 10 minus I3 as the substitution equation for small I. So let's do that. So by doing a substitution for I will get minus 2 in bracket 10 minus I3. Let's simplify this. Minus 2I1 will become minus 4I1 plus 2I2. As we discussed earlier, wherever there is I4, we will replace with a 10, so that will become 20 equal to 0. So if you simplify this, we will get the equation minus 4I1 plus 2I2 plus 2I3. This is plus 20, this is a plus 20. Repeat. Over here, minus 2 into 10 is minus 20 plus 20 minus 20 plus 20 will become 0. So ultimately you will get an equation like this as equation number 1. Let's go ahead and apply KVL to mesh 2. Let's start from this register. So it's minus 10I2 plus minus 6I2 minus plus 6I3 plus minus 2I2 and minus plus, which is plus 2I1 equal to 0. So very straightforward. I will write first I1 terms, which is 2I1. I2 terms are minus 10 minus 6 minus 2, which are nothing but minus 18I2, and I3 terms is plus 6I3 equal to 0 as equation number 2. A very straightforward equation you will get. Now let's apply KVL to mesh 3. Mesh 3 is this. Let's start from this resistor, which is 6 ohm. So minus 6I3 minus plus 6I2 plus minus 8I3 and minus 8I4 equal to 0. As we discussed earlier, wherever there is I4, we will replace with a 10. So upon replacing with a 10 and simplifying, we will get 6I2 minus 14I3 plus 80 equal to 0. If I take this constant on this side of equation, the equation I will get is 6I2 minus 14I3 equal to minus 80 as equation number 3. So we are having this 3 equations, 1, 2, 3. Upon solving, we will get the values of I1, I2, I3. So upon solving this, we will get the values of I1, I2, I3 as I1 will get as 4.898 ampere. I2 as 2.8571 ampere, and I3 as 6.9388 ampere. What we want? We want a current flowing through 10 ohm, which is nothing but I2. So current flowing through 10 ohm resistor is nothing but I2, and that is equal to 2.8571 ampere. Direction we mark as downward, so we will keep as it is. So this is a current we get, but this is because of a 10 ampere acting alone. So it is I10 ohm double dash. So we got I10 ohm dash as 0.1429 and I10 ohm double dash as 2.8571. So as per the principle of a superposition theorem, we need to add these two results to get the total current. So total current flowing through 10 ohm will be I10 ohm dash plus I10 ohm double dash. So this is equal to 0.1429 plus 2.8571. So we'll, upon solving this, we'll get this is 3 ampere, and both the current directions we mark same. So we will get a current flowing as a downward direction. So I10 ohm is 3 ampere is the final answer. I hope you have understood the problem. Thank you.